Lesson 73. Okay, lesson 73 is integrals of a to the x and log base a to the x. So I know it's been a couple days because we threw a test in there, but what did we do in 72? Was derivatives of a to the x and log base a to the x. Today we are doing integrals. So I don't know if it's good or bad to learn these so close together, because I'll be honest, I tend to get them mixed up if I'm not careful. Maybe it's just I haven't taken the effort to really thoroughly get them, stuck in my memory. I don't know, but okay. So we're first going to look at the integral of a to the x. And so when we talk about the integral of a to the x, we're talking about an exponential function. Well, picky here.
Jeez, Trevor, just listen. We didn't even do anything hard yet.
A date on the paper, and I have boxed the paper. Or boxed the integral.
Yeah, but I figured you probably want to know before we started.
It's good to know before I get too far. I do agree. As much as they're going to harass you, I do agree. It's good to know before I get too far here. Okay, so integral of a to the x. So we're talking about those exponential functions, right? 2 to the x, 3 to the x, 4 to the x, just not e to the x. Although technically, guess what? E to the x could fit these rules. Okay? So, integral of a to the x is a to the x divided by natural log of a. And of course, if it's indefinite, plus c. Okay, let's do the easy example. Example 1. What's the integral of 143 to the x dx?
143 to the x over ln of 143 plus c.
I like the other group. It's everything else.
I like that one.
Okay. Note I said let's start with the easy one. We got the easy one out of the way, right?
Yeah.
And that's, again, it's just work on getting this committed to memory. Okay? That's what it has to happen. And I'm sure you guys won't really worry about but the night before the next test. Or not next test, 2 tests away, right? When we have to do the integral. Next test, you'll have the derivative on there, but not integral yet. Okay. Example 2. The integral of x times a to the x squared minus 2 dx. Okay. Because it is a more complicated power that involves a chain rule, and there's that x out front, your best bet would be to do a u substitution. I'm not going to say you'd have to, but that's obviously how I'm going to teach it on day 1 here. Okay. So if we do like a u substitution, what does u need to be? Okay, that power, right? The x squared minus 2. Because then what we'll be able to do is we'll be able to use this as a to the u, which that we'll be able to fit that into our definition. Okay, so what is the derivative of u? So derivative of u is du, derivative of x squared minus 2? 2x dx. Okay, how does this go about matching up with what's in the problem?
Divide du by 2.
Yeah, we have the x dx, don't we? But we have that extra 2 that doesn't match up, so divide that 2 to the other side. And we know that x dx can be replaced with, you can say du over 2 or 1/2 du. Okay, so let's rewrite this integral. A to the x squared minus 2, I am going to rewrite as a to the u. In other words, a to a power. What about x dx? What is x dx going to be replaced by? Du over 2, 1/2 du, whatever makes you happy there, right? Now, officially, when I rewrite this, I'm going to take that 1/2, and where am I going to put it? Yeah, I'm going to put that 1/2 out front, so then it's 1/2 times the integral of a to the u du. Well, good news is this nicely fits into our rule, doesn't it? Keeping the 1/2 out front, what's the integral of a to the u? A to the u over natural log of a plus c. Am I done?
Plug in U.
Plug in u, right? We've got to go back and rewrite this somehow or another. So I have 1/2 a to the u, which is a to the x squared minus 2 over natural log of a plus c. Off the screen. At this point, it just comes up to cleanup options. I'm trying to think what's the best. I mean, one option, you can make this one big fraction, right? You could say that this is a to the x squared minus 2 over 2 natural log of a plus c. The other option I would think you might see is that denominator 2 natural log of a is all constants, right? Those are numbers because a represents a constant here. And so I could also see them pulling that out front as a coefficient. And so putting, it'd be 1 over 2 natural log of a, and then still times a to the x squared minus 2 plus c. That's the one I have boxed on my answer key. I'm not saying any of the others are bad. I always tell you in AP that it's about knowing equivalencies, right? Can you recognize that all three of those are the same? You know, and I say that because that specifically applies to multiple choice, which is half of your AP test. Okay, that was a fun one, right? Gotta get that U substitution in there right away. Don't want to make it too easy on you. Ready for example 3? Not that you can really get a choice, I guess, but
We're halfway through the examples.
we are. I know, it's a good day. It's a good day to get caught up on everything that we're behind on in here, I hope.
Technically, I could walk out of the room, but
You could. Not going to deny that. Okay, example 3. Find the volume of the solid obtained by rotating about the x-axis, the region bounded by the graphs of y equals 5 to the x over 2, x equals 3, and the coordinate axes. No. Well, I'll be honest. I don't know if you guys just saw me. Well, first of all, there's no way. My eyes are getting too old. There is no way I can read if that's an x or a pi. But I looked at my notes at previous year. Okay, I used x over 2 last year. Now, and the other thing is, think about it. If it was pi over 2, 5 to the pi over 2 is just a number. Yeah, it's just going to end up a straight line because that's a constant. It's a weird constant, but it's a constant. X over 3 is a constant. Coordinate axis is a constant. We just created a rectangle at that point. And come on, guys. We're integrating with exponential functions here. So 5 to the pi over 2, x. Not who you were talking to, but. Okay. So it said the coordinate axes, right? So I'm going to draw myself a graph. And it said y equals 5 to the x over 2. Well, what would be 5 to the x? An exponential, right? Which starts over along the x-axis on the left, crosses through 0 over 1, goes up, right? Okay, so the x over 2, that's going to be more of like a shrink. Okay, it's going to just take it longer before it goes up. So it's still going to come from over here. I just am not really drawing it over there. Cut up, and I'm just going to make it take a little bit of time. But it's just not going to go up as quickly because of that x over 2. Okay, what about x equals 3? There's our nice vertical line. Okay, so we're finding the volume of the solid obtained, bounded by those two in the x-axis, so it's honestly not too different from a rectangle. We're rotating about the x-axis, and since we're rotating about the x-axis, the dx that we're rotating dx, and dx is that vertical rectangle, yes? So it's going to make that slice, that circular slice when it rotates about. Okay. Volume means to integrate. Oh, pi. Do you guys remember that? When you're rotating, you have to use, I think it's like pi r squared, right? Yeah, except that our radius is whatever the function is, okay, because that's going to be the radius of the circle. So we're going to do a pi. Our function squared, what's the function we're rotating? It's that 5 to the x over 2, quantity squared. Of course, I need to tack on a dx. What about boundaries, limits? 0 to 3. Because since we're in terms of x, you're going on the x-axis. And they made that part easy on this one, didn't they? So 0 to 3. Okay, let's clean up a little bit. I'm going to pull that pi out front. 0 to 3. 5 to the x over 2, quantity squared. Yeah, because when you raise a power to a power, you multiply powers, right? So x over 2 times 2 is going to make this 5 to the x. Well, at least that part's going to be nice, right? So I have pi out front. What is the integral of 5 to the x? Okay, 5 to the x over natural log of 5. Evaluated from 0 to 3. Okay, you guys know what to do, right? Pi, and then it's going to be 5 to the third over natural log of 5 minus 5 to the 0 over natural log of 5. No plus c, because I just plugged numbers in. Now, we could have done it earlier. We can do it now. Both of those fractions have what? A natural log of 5, right? You could go ahead and pull that natural log of 5 out. I mean, I guess it's already a common denominator, so you wouldn't have to, but what I was thinking about doing is writing it as pi over natural log of 5, because then that just means I'm doing 5 to the third minus 5 to the 0, and if nothing else, it just looks less intimidating. What is 5 to the third minus 5 to the 0?
124.
Yeah. 125 minus 1, which is 124. So if we multiply 124 times pi over natural log of 5, I'm going to have 124 pi over natural log of 5 units cubed because it's volume. Okay, you've had a little practice with the integral of an exponent, an exponential. So you're working on locking that into your brain, right? You're going to practice with it. The other one we're looking at is the integral of a log. And we're going to work this using the rule, and then I'm also going to show one other thought, just, to kind of show you how it works. But if we just use this using the rule, okay, log base A of x is 1 over natural log of A times x ln x minus x plus c. Does that x ln x minus x ring a bell? It's the integral of a natural log. Okay, so let's go ahead and write the answer out using just the rule, and then I will kind of talk about how the log relates to natural logs. So, okay, so what's the integral of log base 23 of x dx? 1 over natural log of 23 times x, whoops, not times x, whoops, x ln x minus x, and then don't forget, it's indefinite, so plus c, correct? Now, connecting thought here. Okay, we were asked to integrate log base 23 of x. How do you rewrite log base 23 of x using natural logs? Yeah, you remember your change of base formula for logs? Okay. It's always it's always the inside of the log over the base. So it's natural log of x divided by natural log of 23. Okay, that's an equivalence that you're familiar with, right? That's change of base formula. I think technically you learn it in Algebra 2. Okay, but so I want to just show you real quick. What if I had integrated this instead? Natural log of x over natural log of 23 dx. Well, natural log of 23 is a constant. So a constant can be pulled out front, right? And we can pull it out front in the denominator. So if I pull that out front, it's 1 over natural log of 23 times the integral of natural log of x dx. And the integral of natural log of x from a couple of days ago is x ln x minus x. So then you have 1 over natural log of 23 times x ln x minus x plus c. Huh? Well, now, my point in doing that is as long as you remember natural log of x, the integral of the natural log of x is the x ln x minus x. But if you get stuck on, oh, I don't remember the integral of log, You can kind of convert here to help yourself along. I mean, either way you go about it, you have to remember the XL and X minus X. But, memorize the rule, change a base formula, however you want to do it there. Okay?